introduction. Hey, it's so nice to be here. I am Tim. Here's me. tholman.com is my website. Here's my Twitter. Here's my GitHub. Here's my LinkedIn. Here's my CodePen. Those are my avatars throughout the last 5 years, and if you kind of play them backwards, it looks like a budding software developer slowly questioning his life choices, really. That was totally by accident. If it goes this way, it's like I'm growing hair and escaping. You may know me from, so I've done a ton of websites online. I've done a ton of products throughout the past ever. Here's one that I made, which was kind of a library where you would scroll down to the end of the page, and it would take you back up to the top. And it would play elevator music, which was nice. Very, riveting stuff, very important. So this is a website, The Useless Web, and you would click this button, and it would take you to random websites like this one that's just a mango. This is a library that I released last year called obnoxious.css, and it's fantastic animations to get the attention of everybody, literally. This is a website that I have Inspiring Online, where I just kind of collect cool stuff that I see. You might have seen these little GitHub corners. They kind of wave to you. Wherever you see those, like, oh, that's me. You might have seen my LinkedIn profile, where I post pictures of dogs. Like all over the place. And I'm here today to talk about generative art. And the reason that I want to talk about generative art is that it kind of holds a very close spot to my heart, in that it's kind of what got me into development. When you start developing, you see so many people creating so many different things, and you can't help but really compare yourself to them and say, oh, how are they doing this so well? How are they doing this? And it's difficult to really get going and get creating. And generative art kind of provided an avenue for me to make something that I felt like people hadn't seen before. So generative art is art that in whole or in some part has been created with the use of an autonomous system. So an autonomous system in this case will be a random number deciding to go left or to go right. You could roll a dice, and if the number was 1, you would do one thing, and 2, you would do another thing. That's an autonomous system, something out of your control. And a speedrun is a playthrough of a game with the intention of completing it as fast as possible. Obviously, we can't complete development, maybe, but I just kind of want to give everybody a very, very quick view over of what they can do and how simple it is to do this kind of stuff. So the steps are, 1, I'm going to break it down. I'm going to show the kind of procedurally how to make more and more complex things with JavaScript. I'm going to kind of show the experimental nature of this, how you can change one small thing and have a huge effect on the other side. And then the third step is to kind of get a little bit introspective, which is something that I like to do in conferences just because it's like, oh, I just spent all this time putting a talk together. What did I learn, and what ideas did I have while doing this stuff? So let's get going. I'm going to introduce you to this idea of a tool belt, which is kind of how development works in the first place, really. When you start developing, you pick up piece by piece, like, oh, I know how to do functions now. I know how to do loops. I know how to do this, that, and the next. And it kind of expands, and your tool belt is kind of what gets you going. So we're going to do a generative art tool belt, and the first thing here is a line, a simple line. Here's how you do it in JavaScript. I show a little bit of code, but not much, because the point isn't really how to code this. It's just a theory. You could do it with any language in any place, but this is how you would draw a line, send some setup stuff in JavaScript. You would have a context, which is your canvas. You would say move to a position, and then you'd say line to a position, and then you say stroke, and the line will appear. So this is what that looks like. Here's a line going from left to right, right to left. Here's an instance of the line going from the top left to the bottom right. In that little frame. Oops. So that isn't quite generative art just yet. We need like a small element of random. So here I'm doing map.random is greater than 0.5, which gives us around about half a chance that'll be true or false. And then here I'll either draw it from the top left or the top right. And so each time I click here, I'm kind of refreshing, and it's going one way or the other. Still not quite generative art. It's just a line. So let's not get too excited. But I'll introduce something new to the tool belt, tiling. So tiling is just like tiling your bathroom, really. I've got a function here that draws a line from the top left to the bottom right. But what if I draw it 4 times? Now it's kind of a little bit more abstract. If I draw it 8 times, 8 by 8, if I draw it 16 by 16, more and more complex. And this is generative art. This is one of my favorite pieces. I first saw it in Google I/O in 2011. Somebody had coded it on a Commodore 64. But you can just kind of see how the simplicity of just drawing diagonal lines from one way to the other way and then tiling it over and over and over and over again has an effect that's way more complex than you would think. And I just love it. And that's where we're going with this talk. So you can do the same thing here with, say, a vertical and a horizontal line. It's like, oh, I've got the framework out there. I can start creating kind of piece after piece after piece. So that's lines, that's tiling. Next, we'll add displacement. So displacement works as so. Imagine I have all these lines running across the screen, and they're made of single points. So with displacement, I'm going to start moving those points around, and the lines, of course, are going to follow them. I'll take the dots away. So this is kind of generative art. It's not particularly exciting. You can get more dense with it. But what if we did something, say, displace the ones to the furthest right and to the furthest bottom more so than the ones on the other side? Then we kind of get something that looks a little bit more arty, and we can make it much more complex. This is kind of an example. I'm showing a ton of things that I've drawn from the web, and I'll link them all to the end. This is an Anders Hoff. So here we have three things, and we're just using lines and displacement at the moment. So the next thing, if lines are our simplest tool, the next most complex one would be curves. So this is how you draw a curve in JavaScript. You move to a start position, you do a Bezier curve too, and you give it 2 control points, and then do a stroke. I actually kind of found this fun just way of like looking at how a Bezier curve actually works. So that central dot is the curve that it actually draws. And so if you had a ton of control points, you get this really kind of complex subsystem that's actually showing how the curve would work. Isn't that fun? So curves. If we do the tiling again and say have these, we can get more and more complex in this kind of completely different way. And again, it's the same thing. We've just gone from drawing a line to drawing a curve. It's still just an if statement and a few different kind of options in there. Here's what the curve would look like in the Anders Hoff example. So you can kind of start to see that we're mishmashing techniques, which is all programming really, and getting different results. Here's the joy division, which is the same principle exactly, but in the center we're displacing them more from the edges, and we're only displacing them upward. So let's add repetition to our tool belt. Repetition in JavaScript is essentially a loop. So here's a line that's been displaced along the page. What if I draw it again and I displace it again and again and again and again and again and again and again? You start to get something here. What if we do it hundreds and hundreds and hundreds of times? We start to kind of see this evolution, this kind of weird, wavy, hairy-esque creation. And every single time you do it, you're going to get something completely different. These are just generated on the fly over and over and over and over again. So that's displacement. Here it is again on our Anders Hoff example. Now it's really something completely different from our first kind of diagonally liney one. But the thing is, they're all different, and they all kind of stand on their own. I kind of like the other ones a little bit more, but when you add the techniques to each other, you start to get some crazy stuff. So now we have 8 examples, and again, we're just messing around with lines on a page. So shapes would be the next thing. If you go lines to curves, shapes would be our next most complex thing. In JavaScript, with the canvas, you can do a rect, which will draw a rectangle, which can be a square or whatever, x, y, and a width and a height. You can draw an arc, which is a circle, and then really you can just draw abstract shapes by going move to, and actually that's wrong, line to, line to, line to, line to, and then stroke. So here's another example with tiling where I've got triangles and circles and squares, and as I get more and more complex, you get something different every single time. You can kind of keep going, and it just turns into white noise. Here's using squares and then using displacement. This is a really cool example where we're using our random element to kind of rotate them, or we're going to use our random element to shift them up and down, left and right. And this is called cubic disarray. I think it was from the 70s, was this first kind of computer art. And it can be as simple or as complex as you kind of want it to be. But either way, you kind of created something here, which again, I feel like is complete and nice. I'd hang it on my wall. Awesome. Again, let's do a circle, and let's now combine it with displacement. So there's our kind of displacing the curve, and again, we can draw it kind of over and over and over and over again, and it starts to kind of create these weird, eye-esque shapes. Always different every single time. We can add recursion. We all know recursion from code interviews, and that's about it. But recursion, if you're not familiar, is when you call a function from within itself. So here we would draw, and then that draw function we call draw again. It's insane. And then thankfully we have a case up here, the break case, where we kind of try to stop it and say, hey, don't recurse forever. So if we had a square, we could draw internally and internally, internally, and internally within that square. And then we could also add displacement, so we could draw it to the left up, or the right, or the down. And then we could use tiling on something like this, and we're going to have these guys. And these, again, can be as simple as complex as you like, but it just kind of stands alone in its simplicity and its beauty. Here's a triangle. If you do recursion on triangle, you kind of get this Sierpinski's triangle. But we can take a step back, and we can start to do displacement on this. We can start to displace it a ton of times, and it's always going to be different, and it's always going to be weird, but it's always going to be art as well. Recursion, again, this is kind of one of the most common versions of recursion, is the tree. So we draw up two, and then those two will split into more, and those will split into more, and those will split into more, and they'll get thinner and thinner and thinner because we're doing a tree. And that's kind of arty in itself, but we could say arrange them in a circle, and we could get hella complex with it, and we're going to get this freaky Eye of Mordor kind of thing. And it's the same, it's just kind of the repetition and the displacement, and we're using these simple tools, and we're just kind of adding them as we go to create something different every time. So here's our large amount of examples. And we're still kind of going. So colors, it's crazy that I have got this far without adding colors, because of course we all know colors. And colors in generative art kind of needs a little subtract because it's interesting in its own. So how do we generally make colors? A lot of the time, especially with web, we start with our hex, our R, G, and our B. But this kind of doesn't work when you want to add a generative element to it. Because every time you refresh, you kind of see I'm getting all these kind of dull, gross, grubby colors. And you can't really trust a machine that well to pick your colors for you. One technique that people use is HSV, hue, saturation, and lightness. In that sense, you can kind of set a place in the color wheel, and you can rotate the hue, and at least you'll have a kind of similar subset of colors. But colors are inherently complex. It's so detailed, and there's so many methods, and they kind of exist in this circular space. I mean, it keeps going on from that, but the colors that you want. So here's like how you would pick monochromatic colors, and if you're coding something like this, or triadric, which are opposite each other, it just kind of adds this complexity, and it makes it really difficult to get to. I found this awesome blog post called From Hex Codes to Eyeballs, just kind of talking about how colors go from your computer to your eye, and you can kind of start to get a sense here, like scrolling through this thing that is insanely complex. And so one of the things that I like to do is just kind of cheat and go on a website where a human has used their actual eyes to pick a color palette, and then we can just kind of randomize from there, which is a nice way to do it. So here's using shapes with colors, and again, we're going to start to get kind of more and more complex, a little bit stranger, but again, beautiful. Like we've just added colors to something that we've just done 5 minutes ago, which is just deciding, should we do squares, should we do triangles, should we do circles? Here's an example from a website called Rectangle World. So here again, we're just doing a line, and we're kind of curving between each side, and you can kind of see how this can get more and more complex as you go through. And then if we add something like colors to it, we're going to start getting, all sorts of kind of weaving creations. And this is just kind of randomized colors across the board. If we do something like this, we kind of have like a poignant red line through our creation. Here's an example of using that displaced circle, but kind of moving it across the screen and repeating it. And you can kind of see how like the lighter colors impose on themselves and get kind of darker, and they kind of mix in a really nice way. And it's just kind of incredibly satisfying to watch. It's like, oh, let's do one more. Yeah, you never really would look at something like this and go, oh, I know exactly how that was made. They just got a circle and they kind of scribbled it across the page. But I like it. It adds a nice element. So here's another recursion example with the circle. So here's a circle, drawing in a circle, drawing in a circle, drawing in a circle, until it stops. But what if we, say, did 2 circles in each circle? So you can kind of start to see how it's getting this hourglass effect, and it's getting more and more complex. If we did 3 circles in each circle, funnily enough, Sierpinski's triangle comes back. We can never escape it. If we did 4, we're going to start to kind of get these matted, complex effects. If we do 5, yeah, it's like a tesseract or something, hexagon of death. And it just kind of keeps going. So if we add colors to it, and each one, say, is a light blue, which I'm doing here, you can kind of see how the center area gets like much darker and much more illuminated. So here again is our, what do I call it, hourglass, Sierpinski's triangle. Once we start to get into these kind of complex shapes, the colors start to overlap, and it just kind of has infinite complexity, which is crazy because we know we're just drawing circles inside of circles inside of circles. And then you can start kind of adding the generative elements to this where your colors are going to be randomized and your variables are going to be randomized. And you're going to be creating something that's unique over and over and over again. And again, that's kind of what got me into the development. It's just the knowledge that nobody's probably seen this before until I've made it, and I can kind of share it out. And it's a blank, clean, sharp canvas. So next, it's kind of starting to get more and more complex here. The next is algorithms, and we all know that algorithms are a word used by programmers when they don't want to explain what they did. And that's exactly what I'm going to do to you all now. Noise is a really, really big one. This is an example I took from CodePen. So you can kind of see there's a vector field here, and each of those arrows kind of represents which direction is pushed. You could almost imagine it as wind, and this little bug is kind of going through them, and it's influenced by this field. So if the field changes, the thing is going to kind of twist and turn and go into a different direction. But if we take out the one bug and, say, add a ton of them, we're going to start to get this really kind of complex, again, it kind of looks like wind on a map field. And this is something that you see a lot of in generative art as well because it's so tempting. It's impossible to stay away. And so every time you kind of randomize it, you're going to get the wind kind of flowing in a different direction, and the creations are going to be completely different. And you can kind of go as more complex. You can have them really, really dense like that. You can kind of stuff them out. We can put it in a circle, put it on a wall. We can start to go into colors with these as well, which is really cool. And as it slowly and slowly develops, you can kind of see the sharpness of the green in the kind of deeper areas and then the kind of lightness in the others. And it doesn't really matter what color you use. It's going to look awesome. Noise, so cool. Is there another one? No. Yeah, and then at this point, we can kind of start to add other inputs into our creation, and these other inputs can kind of just decide which way things go or which way things look. So in this example, I've got the Mona Lisa, which I painted, and if I kind of randomly scrolled across that and sampled each square and took them away, I'd have this kind of weirdly minimalistic Mona Lisa, which is cool in its own sense. But then we can start to add things, again, from our kind of bucket of tools. So we can add the kind of recursion, and we can have our circles recurse in on each other, and we'll get this beautiful kind of abstract one. We could do squares. We could paint it like Lego blocks or something, which is like this. Lego Mona Lisa. Fantastic. We can mess around with microphone inputs. Any audio, any audio visualization that you've seen ultimately is generative art, and these are super cool in their own. I can kind of pause it, and you can see the complexities of it just kind of reading the audio. And then with something like this, you could take it as far as you want. You could kind of tile it, you could twist it around, you could add colors just based on the noise. You can just kind of go and get more and more and more complex. So here's our kind of huge subset of creations that I'm going through in this demo. I kind of want to get into the retrospective-esque part of the talk. And so when I was creating this talk, the idea of the tool belt massively stuck with me, just because I wanted to break down generative art to be as simple as possible. But we don't often look at bigger problems and kind of break it down when we're trying to show them. You go in a lot of the time with like, here's your assumed knowledge, or here we're just jumping straight into it. And tutorials and things online are kind of an interesting example of that, just kind of looking at how we learn and where we get our information from. So we have things like the MDM, we have tutorial websites like CodeDrops, we have Stack Overflow, of course, and they kind of provide a certain amount of value, but they kind of provide a snippet of value. We have websites like CodePen, JSBin, JSFiddle, and more recently Glitch, which kind of provide examples of where you can go into a running example of code and you can kind of play around with it. And sometimes that helps you learn. Sometimes that gives you the final little step that you need to solve the problem that you're looking at. And more recently, and for especially younger generations, a lot of people are learning from websites that are videos. So live streams, the coding train, kind of someone will sit there and explain a certain concept through you. And I just kind of wanted to play around with this, and I wanted to mess around with what I thought might be a kind of new, ideal way of teaching things. And generative art was really a perfect avenue to do this. So I've been making something that I'm calling tutorial Markdown, and you would write, say, a regular post in Markdown, and I'm just kind of adding a few little tags. So there's like a setup HTML tag and a setup style tag, and then as you go through your document, there's just a few more kind of meta examples on the code that you would be showing off. So there's TMD trigger, which says, hey, this is a block of code that is important for my tutorial. This will all make sense at the final step. There's a data from, which is just saying, hey, I'm inserting this code into an editor. What line am I going to start, and what line am I going to end? And it's crazy, and then there's just an action, which would be replace or inject. So if you think about yourself coding, all you're really doing is putting things in between certain lines or replacing certain lines, with things. So this is what I've been making, and this is an example of it that should be released this week, I'm hoping. So you can kind of see, here's my tutorial. Here's where I would have a code block, which so many tutorials are like. You can see here, this is an iframe that will be running the code, and then you can see here, this is a code editor. So as you scroll through, we're going to start kind of seeing the code kind of put itself into the editor. So we can kind of get through, and it's like, oh, we're drawing a line there. Oh, I didn't quite understand that. I can step back. I can look at it again. Here's a complex section. I can go in there and try to understand it a little bit more. And then we kind of get more and more complex, and by the end of it, we kind of have our generative piece. Thank you. And so then you can kind of go in there and you can edit it and kind of go like context.line width equals 4, and you can kind of edit your own code and kind of run it in there, but you're not really at risk of kind of getting defunct from the tutorial as you go through. So keep an eye out for that. Again, that website should be out this week. It's online at the moment, actually, generativeartistry.com, but it's a little bit jank, and it's just got that main tutorial. And then the tutorial Markdown system should be following it very, very closely. Here, again, you can tweet me at TW_Holman. Here are all the examples that I used, and I'll share these slides out as well. So many of these things were kind of taken from works that people have made, where I was like, oh, I just want to kind of break down and show everybody how this stuff was made. Thank you so much for having me.